Hello students, today's lecture is about system database. A database is essentially a computerized record-keeping system. Each unit of information you create is called a record, and each record is made up of a collection of files. Typically, a single record consists of a set of file names like title, first name, surname, job title, no, and ID. You fill in a form with the relevant information for each file to add a new record to the database. There are different types. Text holds letters and numbers not used in calculations. Number can only hold numbers used in calculations and reports. Memo can store long texts. Date, time, a date or time or combination of both. Auto number assign a number to each record. OLE object. Object linking and embedding holds sounds and pictures. Yes, no for alternative values like true, false, yes, no, on, off, etc. Hyperlink adds a link to a website. A database is an organized collection of data. It is the collection of schemas, tables, queries, reports, views, and other objects. A database management system is a computer software application that interacts with the user, other applications, and the database itself to capture and analyze data. A general-purpose DBMS is designed to allow the definition, creation, querying, update, and administration of database. Well-known DBMSs include MySQL, Postgresql, Microsoft SQL Server, Oracle, Sybase, and IBM DB2. Formally, a database refers to a set of related data and the way it's organized. The DBMS provides various functions that allow entry, storage, and retrieval or large quantities of information and provides a ways to manage how the information is organized. Outside the world of professional information technology, the term database is often used to refer to any collection of related data, such as a spreadsheet or card index. Next, existing DBMS provide various functions that allow management of a database and its data, which can be classified into four main functional groups. First, data definition, creation, modification, and removal of definition that define the organizations of the data. Next, update, insertion, modification, and deletion of the actual data. Third, retrieval, providing information in a form directly usable or for further processing by other applications. The retrieved data may be made available in a form basically the same as it is stored in the database or in a new form obtained by altering or combining existing data from the database. Next, administration, registering and monitoring users, enforcing data security, monitoring for performance, maintaining data integrity, dealing with concurrency control, and recovering information that has been corrupted by some event such as an unexpected system failure. A database model is a type of data model that determines the logical structure of a database and fundamentally determines in which manner data can be stored, organized, and manipulated. The common models include relation model, data independence, hierarchical models, links but no cycles, network model, any links supporting quick access, object-oriented model, entity abstraction. A database management system provides three views of the database data. The external level defines how each group of end users sees the organization of data in the database. A single database can have any number of views at the external level. Next, the conceptual level unishes the various external views into a repeatable global view. It provides the synthesis of all the external views. The internal level is the internal organization of data inside a DBMS. It is concerned with cost, performance, scalability, and other operational matters. Relational model: a database based on the relational model developed by E. F. Cott. A relational database allows the definition of data structures, storage and retrieval operation, and integrity constraints. In such a database, the data and relation between them are organized in tables. A table is a collection of records, and each record in a table contains the same fields. The relational model for database management is a database model based on predicate logic and set theory. It was first formulated and proposed in 1969 by Edgar Code with aims that included avoiding without loss of completeness and the need to write computer programs to express database queries and enforce database integrity constraints. The foundation for the relational model included important works published by Gerd Cantor and D. L. Schultz. Cantor was the 19th-century German mathematician and published a number of articles and was the principal creator of set theory. Schultz is an American mathematician whose descriptions of a set theoretic data structure was cited by Code in the seminal 1970 paper of a relational model of data for large shared data banks. Hierarchical model: the hierarchical data model organizes data in a tree structure. There is a hierarchy of parent and child data segments. This structure implies that a record can have repeating information generally in the child data segments, data in a series of records which have a set of filed values attached to it. It collects all the instances of the specific record together as a record type. To create links between these record types, the hierarchical model uses parent-child relationships. These are first, and mapping between record types. This is done by using trees like set theory used in relational model borrowed from MES. Hierarchical DBMS were popular from the late 1960s with the introduction of IBM's information management system DBMS through the 1970s. Network model: the popularity of the network data model coincided with the popularity of the hierarchical data model. Some data were more naturally modeled with more than one parent per child, so the network model permitted the model of many-to-many relationships in data. In 1971, the Conference of Data Systems Languages formally defined the network model. The basic model modeling construct in the network model is a set construct. A set consists of an owner record type, a set name, and a number record type. A member record type can have that role in more than one set, hence the multi-parent concept is supported. An owner record type can also be a member of owner in another set. The data model is a simple network and link and intersection record types may exist as well as sets between them. The complete network of relationship is represented by several pairwise sets. In each set, some record type is owner and one or more record types are members. Usually a set defines a 1M relationship, also 1 and 1 is permitted. The codicil network model is based on mathematical set theory. Three types of relationship in an ARD diagram. There are three types of relationship that can exist between two entities. An entity relationship diagram is created based on these three types, which are listed below. One-to-one relationship, In relationship database design, one-to-one relationship exists when 0 or 1 instance of entity A can be associated with 0 or 1 instance or entity B, and 0 or 1 instance of entity B can be associated with 0 or 1 instance of entity A. One-to-many relationship. In relationship database design, a one-to-many relationship exists when for one instance of entity A there exists 0, 1, or many instances of entity B, but for one instance of entity B there exists 0 or 1 instance of entity A. Many-to-many relationship. In relationship database design, a many-to-many relationship exists when for one instance of entity A there exists 0, 1, or many instances of entity B, and for one instance of entity B there exists 0, 1, or many instances of entity A. There you can see one-to-one, next one-to-many, next many-to-many. One-to-one relationship. A single entity instance in one entity class is related to a single entity instance in another entity class. For example, each student fills one seat and one seat is assigned to only one student. One-to-many relationship. A single entity instance in one entity class is related to multiple entity instance in another entity class. For example, one instructor may teach many students in one class, but all the students have one instructor for that class. Many-to-many relationship. Each entity instance in one entity class is related to multiple entity instance in another entity class and vice versa. For example, each student can take many classes and each class can be taken by many students. Each consumer can buy many products and each product can be bought by many consumers. Next, last one, look at this form of a music collection. Label the data types. So we have finished our lecture. Thank you for attention.